Okay, so the last video we're going to look at is how hormones use plants for coordination. So, in this case, we've got a Venus flytrap. What's going to happen next? Hopefully for the Venus flytrap, it will respond to the stimulus, which in this case is the fly, and close it. And you should try and have a look and try and work out how that actually happens in the plant. We're going to be looking at how plants respond to the kind of normal stimulus, mainly light and gravity that they experience, and the role of auxin in the phototropic response. So, as I said, that's hopefully what the Venus flytrap will get. If you set off a Venus flytrap lots of times without flies in, it will die because it takes a lot of energy for this to occur. So plants, often people don't really think plants are sensitive because it takes quite a long time to see them do anything. However, they do respond to certain stimuli, and they have hormones which are important in this response, and the one you need to know about for your IGC is auxin. So a tropism is a response to a stimulus. We're going to look at negative and positive tropisms. A positive tropism is a growth towards a stimulus, a negative tropism is a growth away from a stimulus. You also need to know about phototropisms and geotropisms. Phototropism is a response to light, and the geotropism is a response to gravity. So, if you've got a table such as this, you can work your way through it. So you can have a go, pause the video to have a go at that. So to work out the answers, you have positive phototropism. It happens in the stem tip because it's only the tip of the stem where the cells produce auxin. You get growth towards light because it's positive, and you get maximum light for photosynthesis. Negative phototropism happens in the root, so it goes away from the light. Again, it's a root tip because that's the only bit of the cells which produce auxin. Less chance of drying out if it's away from the light. Positive geotropism, again in the root tip, it's towards gravity, so more chance of finding moisture in the soil. Negative geotropism is in the stem tip, and it grows away from gravity, so there's more chance of finding light. So in phototropism, you need to be able to explain why plants grow towards the light. So auxin is a hormone which is involved in this, and it causes the cells to enlarge or elongate in the tip of the stem. So it's made in the shoot tip. When light is coming from one direction, the auxin diffuses through the plant and accumulates on the shaded side. So the shaded side of the plant, you get more auxin. This causes the cells to elongate on the shaded side, and because these cells go longer, it causes the tip to move towards the sunlight. As soon as the shoot is growing towards the sunlight, the auxin will be evenly spread and it will just start going straight towards the sunlight. So, tropism experiments are another thing which are quite useful to look at, and we'll have a look at those in a minute. For geotropism, auxin also cause a response to the stimulus, which is gravity, but in roots it works the other way around. So if you place a root horizontally, auxin will accumulate at the bottom of the root due to gravity, and in roots it inhibits the growth. So the upper side will grow faster because the cells will have more elongation, and so the root will grow downwards. The upper side will cause it to grow downwards. If you put a plant horizontally on a clinostat, which rotates very slowly, there's no effect of gravity, and so the plant starts to grow straight across. So if we were going to investigate the effects of different things on plants, you could have a box like this. White light for more directions is the control, so you can compare your results. The dependent variable is how the plants grow. The independent variable is the one we're changing, which is, in this case, the filter, or the amount of light the plant's getting. So you can have a go at trying to fill these in and see what you think is going to happen. So hopefully now you've had a look at geotropism, phototropism, responses to roots and stems, and how auxin is the hormone involved for these responses.